channel and in Coaching Center. So today I'm going to explain 12th standard physics 6th chapter, that is Waveoptic. So let's come to the chapter. So the first topic of the Waveoptic is Wavefront. Wavefront. The wavefront at any instant is defined as the locus of all the particles of medium which are in the same state of vibration. They are in the same state of vibration, or an imaginary surface passing through particles, or oscillation particles. Oscillation with the same phase is known as wavefront. So what is the meaning means? An imaginary surface passing through particle oscillating with same phase, that have same phase, is called as wavefront. So a point source of light at any infinity distance is an isotropic medium, emits a spherical wave. See here you can see in the figure here you can see the source ray that have that makes a spherical wave. Infinite spherical, it is like spherical. See, and a point source of light in isotropic medium at infinity distance, it is infinity distance, will give rise to plane wavefront. So it is plane wavefront. And next in diagram C, it gives rise to a cylindrical wavefront, like this it will be. So this is the wavefront. The meaning is an imaginary surface passing through particle oscillating with same phase is known as wavefront. So this time I asked what is the meaning in your final exam, means you have to write like this. Next let's come to the Huygens law. Huygens principle, what it states as, this time I asked for 1 or 2 months. What Huygens principle states is, every point on a given wavefront may be considered as the source of secondary wavelength which spreads out the speed of the light in that medium. So is considering of secondary wavelength which spreads the speed of light in that medium. Taking that secondary wavelength, it spreads the wavelength to the in the speed of the light in the medium, it spreads. And it also says that new wavefront is the envelope of the secondary wavelength at the instant. So new wavelength is the envelope wavelength of second instant. So how is Huygens construction of a spherical and plane wavefront? So here in figure here it is telling that we have to take A and B representing as given wavefront at a time t is equal to 0. So t is equal to 0. According to Huygens principle, every point on AB acts as a source of secondary wavelength which travels with the speed of light c. And to find the position of the wave from wavefront after at a time t, the time t circle are drawn. See, time t circle are drawn. Time t circle are drawn. And to find the position of the wavelength from after a time t, circle are drawn with point P, Q, or etc. Like this, you have to draw the circle. See here P, Q, or like that. We have see P, Q, or you have to like that, and you have to draw the circle. And AB and radii equal to CT. So AB and radii are equal, and the arc here you have to cut a arc. That arc should be A1 and B1, and the A1 and B1 like that, and A and B should be written as A and B. And in figure B, here you have to write a straight line there. A and B you have to write, not arc. Here you have to write a straight line. Like this, your Huygens construction of spherical and plane wavefront you can draw. And this principle they may ask for your 2 to 3 marks in your final 1 or 2 marks they may ask, and this they may ask in your final exam to draw if they may ask. The next topic is reflection of plane wavefront at a plane surface. So like this only, let us draw xy be a plane reflecting surface. So this xy is a plane reflecting surface. There AB be a plane wavefront. Let take as AB be a plane wavefront incident on the surface at A, PA, QBC, and perpendicular drawn to. So like this only, it will be reflecting perpendicularly Next, the AB at A and B respectively, hence they represent incident ray. So AB represent the incident ray, this A and B, and AN is the normal drawn to the surface. So AN, here straight line you are seeing, no, but normal drawn to the straight surface. Next, by that time the secondary wavelength from B travels to distance BC. So after AB going, then it secondary wavelength it travels from B to B to C, it travels, and the secondary wavelength from A reflect surface would travel from B to C after reflecting. So taking A as center, let us take A as center and BC as radius, B and C as radius, and arc is drawn. So let's draw a arc, a small arc you can see from C. So from here, from C, a tangent CD. So from C, a tangent CD is drawn to this arc. So a tangent is drawn CD, as you know, tangent, that is touching a, see here, it is little bit touching the outside. Tangent means a point it is touching, or it is going in the middle of the circle, as you know. So here CD you can see, then that CD is not enveloped to the wavelength from C and B and A, but also the wavelength from all the points between C and A. So these are the wavelength between all the points between C and A, they makes all the points. So therefore CD is reflected plane wavefront, and AD is reflected ray. So AD is reflected ray, CD is reflected plane. Like this we have to understand. Next is loss reflection. Loss reflection, what it says, in the incident wavefront AB, the reflected wavelength, CD and the reflecting surface XY all lie in the same plane. They all are in the same plane. Angle of incident I is equal to PAN is equal to 90 degree, and NAB is equal to angle NAB is equal to angle BAC we have to take. So angle of reflection R is equal to NAB is equal to 90 minus BAC is equal to angle DCA. So therefore angle B is equal to angle D is equal to 90 degree. So BC is equal to AD, and AC is common. Therefore two triangles are congruent, angle BAC and angle DAC are the congruent, thus the angle of incident is equal to the angle of reflection, hence we have proved. Next is reflection of a plane wave front at the plane surface. If there is a plane surface, how it reflects? So XY as a plane reflecting surface, now we have to take XY as plane reflecting surface, and AB is the incident of the reflecting surface of A. So here AB we have drawn, it is the reflecting refractive surface of A. And let's draw P. Let us draw P. So PA and QBC. So QBC, here C we will get. So P and QBC are perpendicular drawn to AB. So they are perpendicular to AB, and at A and B respectively they are perpendicular, and like that only, by that time the secondary wavelength from B reaches to C, and the secondary wavelength from A would travel to AD. Like that only till D travels, the A travels till D, B travels till C, we have to take. Like that only, therefore BC is equal to CT and AD is equal to C2T. BC is equal to C1T and AD is equal to C2T, we have to take, and taking A as the center, C2T as radius, an arc is drawn in the secondary medium from C. A tangent CD is drawn to this arc. Like that only it is drawn. Law of refraction. Like that only the incident ray of AB. So sin 1 by sin R is equal to BC by AC by AD by AC is equal to BC by AD we will get. So V1 by T, V1T, V2T is equal to V1 by V2 is equal to N21, and therefore lambda 1 and lambda t is denoted as the wavelength. So lambda 1 by lambda t is equal to BC by AE is equal to V1 by V2. Like this we have to take. Next is refraction of plane wave by the prism. First let us see how it reflects in the prism. So plane wave passing through a thin prism clearly since the speed of light. Because of speed of light it is passing through it, and because of speed of light, wave is less in glass. Wave is less in glass because of the speed of light. The waves passing through the glass is less, and the lower portion of the incoming wave front will get delay, resulting in a tilt in the emerging wave front, as shown in the figure. So there will be little bit tilt. See, like this, it will be bending. Next, concave lens, how there will be refraction. So let us consider a plane with incident on a thin concave lens. So the central part of the incident plane wave transfers the thickest portion of the lens and is delayed the most, and the emerging wavefront has a depression at the center, and therefore the wavefront becomes the spherical and converges to the point F, which is known as focus. It comes till focus. So you may have learnt this drawing the image, how the images comes in your ray diagram. You may have learnt in your 10th. Their focus you have learnt till there, it will come the reflect, it reflects in the plane in the concave lens. Next, refraction of plane wave by a concave mirror, how it reflects in concave mirror. So a plane wave is incident to a concave mirror, and on reflecting we have a spherical wave converging to the local point F. So here also it is converging to local point F, focal point F. So what is coherent and incoherent? So two surfaces are said to be coherent if they emit light waves of the same wavelength and they start with same phase, and consist phase and or have a phase different. If it has same wavelength and same phase or different phase, is called as coherent. And if two independent monochromatic sources emit waves of same wavelength but waves are not in phase, so if the waves are not in phase, then they are not called as coherent, they are called as incoherent. So this difference they may ask, what is means? Coherent means they have same wavelength and they are in the same phase or constant phase. They are in the same phase or constant phase. But in incoherent there will be say wavelength, but they are not in there is not phase. They don't have any phase. So therefore it is incoherent source. Next is superposition principle. When two or more waves simultaneously pass through a same medium, each wave acts on every particle of the medium as if the other waves are not present, and they result in the displacement of any particle in the vector addition of the displacement due to the individual waves. If there is addition of displacement due to individual waves, this is known as the principle of the superposition. If y1 and y2 represent as the individual displacement, then the resultant displacement is given by y is equal to y1 plus y2, it is given. And this effect produced by superposition of two or more wave is called as interference. It is called, what is called interference, the effect produced by superposition of two or more. Two, or if two it is there or more it is there, then it is called as interference. And if the resultant displacement of any particle is the vector addition of the displacement due to the individual waves, then it is known as the superposition. So next topic, interface due to the two waves. So here they have given a diagram, S1, S2, R1 and R2 it is consisting of, and P as the line drawn. So after the visible prediction, E1 sin W1t is equal to K1 R1 plus theta 1. Then here they have taken E and 2. So therefore here E1 and E2 are represented as the amplitude of the electric field. So the E1 are amplitude of the electric field, and W and W2 are denoted as the angular frequency of the wave, and K1 and K2 are wave vectors. They are given, and E is equal to E1 plus E2 we have to take. The magnitude of the resultant vector E2 is equal to E1 E2, and E2 is equal to E1 E2 E1 E2 plus 2 E1 E2 cos, like you have to write. And next, the finally after solving this we get is cos is equal to 1 by t by t is equal to t is equal to 0 cos w1t w2t k2 plus k2 r2 minus k1 r1 plus theta 2 minus theta 1 bracket dt is the first equation we get. So case 1 of incoherent surface. So if let us take as case 1 as incoherent surface. If the angular frequency of both sources is not same, thus if it is not same, each time depends and angular value is 0. Thus superposed two waves produce the average intensity L1 plus L2 at point P. So this formula we got here, no, the interface due to two waves, that here formula we got, no, first equation that we will put here again. And there what we will do means we will take I is equal to, now we will take L is equal to, sorry, I is equal to I plus I plus 2 I root I cos R2 minus R1. So therefore I is equal to 2I plus 2I cos. So therefore, so sorry, it is L, so 2L plus 2L cos R2 minus R1. So therefore I is equal to 2L 2 cos 2 K R2 minus R1 will get. So therefore finally we get I is equal to 4L cos 2 K R minus R2 minus R1 is lambda, known as path difference. It is known as path difference. So K path difference by 2. So constructive intersurface. So let us take 4L. 4L is equal to cos 2 K R2 minus R1. So K path difference R2 is equal to, so 2 pi path by path difference by 2 lambda is equal to n pi is equal to, so therefore path difference is equal to n lambda. And we get final and I1 L1 L2 plus L2 L1 L and cos path difference 1 and path difference 2. So therefore I max is directly proportional to A1 plus A2. And in case to destructive interface we get is K path difference by 2 is equal to pi 2 3 pi 2 3 pi by 2 and 5 pi by 2. Therefore it is keep on going, and K path difference by 2 is equal to 2n minus 1 pi by 2 and 2 pi lambda 2 lambda by path difference 2 pi path difference by 2 lambda is equal to 2n minus 1 pi by 2. So therefore path difference is equal to 2n minus 1 lambda by 2 is the thing we get. And again what we do means L1 L2 will take plus 2 L1 by L2 cos path difference 1 by path difference 2. So therefore L is directly proportional to A1 minus A2 whole square. So these are the solved numerical by that using that formula. Here we got no the L is equal to L1 plus L2 plus 2 L1 L2 cos path difference 1 minus path difference 2. By using that formula here they are solved. And conditions of sustainable interface. What are the conditions? So the two sources should be coherent. So there you learn coherent, that have wavelength same and phase also it should be same, or constant phase it should have. And two sources should be very narrow. It should be narrow, and the sources should lie very close to each other to form distinct and both fingers. So remember this, same as in exam 1 or 2 marks. Conditions for sustain in the intersurface. And here solved numericals. They are solved some numericals. So by using the formula they have solved some questions. So they may ask in a final exam problem. So by using that formula here, the sustainable interface formula, and starting till now which is from my explained you, by using that you have to solve. So okay friends, from Young's double slit experiment I will explain in the next video. So till here you have understand, I think so. So okay friends, like my video, comment on my video, and subscribe my channel and Coachingcentre for more video. I will explain the next topics of Waveoptic chapter in my next video. So till then, okay friends, bye, see you, take care, have a nice day, and understand the chapter and practice the numericals and how to write, how to get that formula. Here I said no, solve like this, how to get this constituent intersurface and incoherent surface, coherent surface formula, like that only you have to practice. They may ask in a final exam also. find the formula of coherent interface or the mask in question, and that formula you have to remember. It may help in help to solve the numericals also, and they may ask the numericals in your NEET also, so remember it. So okay friends, bye, see you, take care, see you in my next video explaining part 2 video of this chapter. And Young's I said no, I will continue from the Young's double slit experiment, I said, so I will continue from there. So okay friends, bye, see you, take care, see you in my next video. Till then, take care and have a nice day. Bye friends.